Assalamualaikum warahmatullahi wabarakatuh. Inshallah today I would like to present network analysis subjects, which is on our title is Fourier transform in computer science. Okay, first of all, I would like to introduce myself, which is my name is Muhammad Salahuddin bin Mazizi, and my partner is another partner is Muhammad Najib bin Amiruddin, Wan Abdul Hakim bin Wan Salihuddin, Alki Farhan bin Hairuddin, and the last one is Nick Muhammad Ashraf bin Ni Afrini. Okay, we go to the introduction. What is Fourier transform is a mathematical technique that transforms a function of time to a function of frequency, which is mean from the time domain to frequency domain. Fourier transform is an integral transform, which is every Fourier transform must be in integrable unit. It can integrate, which is me. And the third one is transform a function in the time domain into the frequency domain. Okay. And the last one, Fourier transform can handle circuit with input for t less than 0 as well as the t more than 0. Alright, the Fourier transform equation. Fourier transform equation has two types, which is forward Fourier transform and inverse Fourier transform. There are some point here, which is a frequency domain and time domain, which is a Fourier transform pairs. Okay, this duality also suggests that whenever we have a property of the Fourier transform, then there will be a dual property with the roles of time and frequency interchange. For example, we see in the section XX, below that multiplying a signal in the time domain by a complex exponential corresponds to a shift in the frequency domain. Alright. Next one, application in electrical engineering. Fourier transform is to change time domain to frequency domain. Fourier transform get involved in electrical wave, especially non-sinusoid waveform. Non-sinusoid waveform, which is the main thing in Fourier transform, which is they analyze and they read the signal, and then apply the Fourier transform on it. Okay, basically, Fourier transform has been used in many type of application, which is in medical, in optics, and others. Okay, that's all for me. I would like to pass from the next presenter. Yes, thank you.
Assalamualaikum. My name is Alki Farhan. Now I want to talk about the 3 steps that must be followed to identify the unknown. Okay, first, we must convert all elements from time domain to omega domain. Second is to apply circuit analysis, mesh or nodal to solve the unknown, which is based on the circuit given and analyze what is suitable for the circuit. Third one is convert back omega domain to time domain. Okay, next is application of Fourier transform in computer science. Okay, Fourier transform in computer science is an applied science where one of the application is to solve real world problem much faster. These functions are used in large industrial scale application. All the fancy work of image matching, face recognition, 3D map creation, video processing, sound processing is done using Fourier transform. For example, it's like a mobile phone. Now mobile phone can recognize the user face by face scanner or else by sound. For example, on iPhone we have Siri, which is we can talk or ask to Siri, then Siri will respond to our question. The fourth one is function has the capability to transform analog signal to digital from which can be processed by computer. Next one is Fourier transform in facial recognition. A facial recognition system is a technology capable of identifying or verifying a person from a digital image or a video frame from a video source. So they work by comparing selected facial features from given image with face within a database. It extract frequency features of a face rather than analyzing the image pattern using a convolutional network. The main idea is to find the most variant frequency in the image database and identify the face by matching this frequency. So next, this is example flowchart. System configuration of face recognition. So from the first, we get the image from video camera, then the face detector will save in face database, then we go to eye recognition, then the eye recognition will save in eye database. Then they go to facial feature extractor to more clear. Then go to face recognizer. Then they save in person database updating. Then go to recognition or reject, which is if your face is same with in database, then you will recognize. If not same with the database, the image will reject. Thank you.
Okay, so hello, my name is Nick Muhammad Ashraf bin Afini. So I will continue the presentation with the face recognition using discrete Fourier transform. So as you guys can see, it is a simple face recognition system based on image analysis using the discrete Fourier transform (DFT). The Fourier transform is an important image processing tool which is used to decompose an image into its sine and cosine components. So in the image processing, often only the magnitude of the Fourier transform is displayed. So if we want to retransform the Fourier image into the correct spatial domain after some processing in the frequency domain, we must make sure the preserve both magnitude and phase of the Fourier image. So this one is the transformation of input from the time domain to frequency domain. At the first step, the image sensor will capture the image. Then it will send to image preprocessing and resolution variation block. So the image sensor also will capture the second image, then send it to the same block as image 1. And the second step, the image preprocessing and resolution variation block will send the data to DFT of face recognition. So from that block, it will produce the low and high frequency. From that, we can analyze the data from the frequency. So low frequency contain much more information which is suitable for recognition compared to highest one. So lower frequency are likely to be found at four corners of image spectrum. Next slide. so low frequency are likely to be found at four corners of image transform. It is to be noted that as we have considered for different pair of operation, the image area is divided into uniform four parts. So to maintain the size of the image, while applying the set operation, the LL, HL, LH and HH, we need to undersample the image. So in the next section, we discuss how the undersample image along with the four level decomposition concept help us to make the DWT a reversible one. Next. So this one is face recognition using the discrete transform. So face recognition has been a hot issue of concern to people. Existing algorithms mainly for how to improve face recognition accuracy and reduce the use of the feature vector dimension. So a face recognition method based on the discrete cosine transform and SVM based feature classification is present. So face recognition on the DCT coefficient as feature vectors in the problem of effective choice. So in the training process of SVM, the training sample is divided into two parts. One part of the training samples using the test result of feature selection and use the resulting accuracy rate as the feature selection criteria. Then the proposed algorithm on ORL face image standard library of verified experiment and achieve good result prove the effective and reliable. So that's all for me.
And next, my name is Muhammad Najib, and I will explain about face recognition stage. First, when a picture of your face is captured from a photo or a video, the system will localize the center line and vertical center line. The center line interact the face vertically into two symmetrical parts. The system seeks the position of the gray level higher on the axis of the eyes. Next. For the second step, it will localize the axis of the nostril and mouth. The axis is the line that contains less than pixel of the skin located below the axis of eyes. It has precise localization then took the area around nostril below the axis of eyes and around the center line. The minimum of the curve which is vertically projection correspond to the axis of nostril. Next. And this is the third step, which is geometrical face model. After the system has recognized the eyes and the mouth, the geometrical model is used to extract the features of the image. Next, and the last step is framing and scaling. This is the last step. After localizing each local face object, the system will try to frame all the features in a single rectangle and resize the image to a specific size of bilinear interpolation. This method is to reduce copulation time. That's all from me.
Hello, my name is Muhammad Hakimi, and I will talk about how it works. So the system receives an input image containing a face along with eyes coordinate. Then it executes both geometry and illumination normalization function as be described later. Once a normalized and cropped face is obtained, it can be compared to the other face under the same nominal size, orientation, position and illumination condition. This comparison is based on a feature extracted using the DCT. The DCT of the normalized face and retain a certain subset of the DCT coefficient as feature vector describing this face. This feature this feature vector contains the low to mid frequency DCT coefficient, as these are the ones having the highest variance. To recognize the particular input phase, the system compares the phase feature vector to the feature vector of the database phase using Euclidean distance nearest neighbor classifier. Next. Okay, this is the example of discrete Fourier transform formula. First, the DFT can calculate the signal frequency spectrum. This is a direct examination of information encoded in the frequency, phase, and amplitude of the component. For example, human speech and hearing use signal with this type of encoding. Second, DFT can find system frequency response from the system impulse response and vice versa. This allows system to be analyzed in the frequency domain, just as convolution allows system to be analyzed in the time domain. The third one, the DFT can be used as an intermediate step in more elaborate signal processing techniques. Next. Okay, coefficient selection is one of the most important parameters in any recognition techniques. Some coefficient selection method are low frequency coefficient selection method, square selection method, and circular selection method. For circular selection method, you can use circular to select either object completely within the selection region, or object either within or touched by the selection shape, or crossing method. Next. Okay, for the conclusion, Fourier transform can be used in many fields, such as computer science, medical, and the other. Like the Fourier transform, the data processing transform is a mixed domain transform. In general case, the input data should be viewed as an image, and then distorted version of the image is desired output. Regardless of the physical meaning of the input and Fourier coordinate, viewing the input and output data each as an image that general application of the transform to any processing step clear. The physical meaning of the transform coordinate and distortion can be defined only when discussing specific processing step. The Fourier transform also can analyze the non-sinusoid waveform, and any space or time varying data can be transformed into different domain called the frequency domain. Okay, that's the end of our presentation about Fourier transform in computer. I hope with this presentation you can understand more about Fourier transform in computer. Thank you.